often do you think about where your food comes from? I know I buy my bread from the store pre-made. But if we stop and think about it, a lot of hard work went into making that bread. Growing wheat from a small seed to a mature grain-producing plant takes an average of 100 days. And during those 100 days, a grower has to manage soil nutrient levels, enact tilling and rotation plans, scout for diseases, and monitor for insect pests. I hope to make that last job just a little bit easier for wheat growers in the Canadian prairies. Insect pest monitoring is usually done in an integrated pest management approach, which combines multiple tools into one comprehensive management strategy. These strategies focus on careful monitoring of pest populations and understanding of biology to determine when control is needed. And when that control is necessary to protect a grower's economic return, different techniques like biological control or cultural control like tilling are considered, as well as chemical insecticides. Now, I work with an insect pest of wheat called the orange wheat blossom midge, and it's a tiny fly. The adults on the screen are about the size of a pinhead, but they can cause huge damages. In one of their first major outbreaks in Canada, they caused $30 million of damage to wheat yields in Saskatchewan alone. That's a lot of lost food and a lot of lost money. Now, the adults don't damage the wheat themselves, but the maggots feed on the grains, shriveling them like on the screen or destroying them. And this is difficult for management because the florets that surround the grain actually protect the maggots from any control methods. So this means we have to monitor for and control the adults. And that control has to come during the 3 to 10 day lifespan of the fly. This makes timing of monitoring critical. My research focuses on improving that monitoring as well as our understanding of wheat midge biology. I'm confirming the accuracy of computer models used to determine timing of monitoring. And by looking at dates of adult emergence, as well as accumulated temperature and rainfall, I can get a clear picture of what factors are driving wheat midge emergence in northern Alberta. So timing is important, but what about the tools themselves? Different traps and baits have been used throughout the years, but we don't really know how well they work or which ones work best. So I'm testing them in real commercial fields to see how comparable that historical data is. My first year of data suggests that they might work equally well in northern Alberta. And I'm taking the data from those traps to try and determine the relationship between numbers of adults in a trap, maggots in a field, and damage that the grower actually sees. And if we understand this relationship, we can advise growers on when it might be in their best interest to enact controls. My research will improve the integrated pest management strategy for wheat midge, and that should make those 100 days of growing wheat just a little bit easier for Canadian farmers. Thank you.